I saw your interview.
This is my space here.
Okay.
So I will, and I'm an educator.
Okay.
So I will require that you don't start your question with the word Okay? Otherwise, you get docked a turn. Okay? So start again, and don't start with Okay? I know it's hard, but it's for the greater good, I assure you. Okay, go.
I saw.
Wasn't that hard? That was hard coming out of her. Okay, go.
I saw in your interview earlier with.
No,
with
ums in the
Times-
middle are okay. Just don't start your sentence with an
With Times Magazine, that you said he asked you.
Was this time 10 questions? The 10 questions interview?
Yeah.
Okay.
Yeah.
A reporter from Time Magazine came into my office and asked 10 questions submitted to the magazine, and then that was podcasted and there's a little video of it. But the podcast has the full answer. The video is truncated so it doesn't bore you on YouTube. But continue, yes.
Okay. He asked you if you could go back in time, which scientist you would choose to speak with, and you said Sir Isaac Newton.
Oh, yes.
And I was just very moved by the way that you spoke about him, and you said that he just like really felt the universe, or he really understood it, and
Isaac Newton was in touch with the cosmos.
right. And you said that he.
But do you have a question, or you just want me to?
No,
Oh.
I was just.
You want me to share that with everyone?
Yeah, I just wanted to know.
You want to be moved a second time, is what you're saying. You were moved that first time, because I'll talk about Isaac Newton. Me and Newton go way back. Okay? Shall I?
Yeah, I wanted
Okay.
you to elaborate, because the way you said it, you said that he.
I will elaborate about Sir Isaac.
Okay.
I will do so.
Okay.
Isaac Newton. He didn't ask me what scientist would I see if I went back in time. He asked me, what person do I want to meet if I went back in time?
Right.
I said, it'll be the scientist, Isaac Newton. Isaac Newton, British scientist. He was a professor at University of Cambridge. He held the endowed chair that Stephen Hawking now holds, the Lucasian professor of mathematics. And he was a physicist. Today we would think of him as a physicist. Back then he was what's known as a natural philosopher who posed questions about the natural world as opposed to the human world. They're human philosophical questions, like the meaning of life and this sort of thing. Then they're natural philosophical questions. What is the origin of the universe and of the world? So Isaac Newton was brilliant. I own most of anything he's ever written. And I sit there and I read it. And as I read the sentences he put to page, hair goes up on the back. I don't actually have hair there, but I feel it. If it would, you feel like the goosebumpy kind of thing. If I had hair on my neck, it would be standing on edge as I see the depth to which he was connected to the operations of nature. There is no doubt about it. The man discovered the laws of gravity by sitting there. Okay, it's rumored that he sat under the apple tree, but what is certain is that he knew in the same field of view, he saw an apple drop and the moon in orbit around the earth. Okay, he sees the two of them. One is falling to the ground and the other is like up there in space. He connects the two and suggests that the same force of gravity is operating on both of them. They're both falling towards Earth. He hypothesizes, well, how's that possible? Because I can drop this camera on the ground, it would fall, okay? But if it's in orbit, it's not falling. But it is falling. It is. If you're in orbit, you are falling towards Earth. He drew a diagram to illustrate this. In fact, that diagram is on the wall over there called orbits. There's someone whose head is in front of the orbit now who's typing on his head. There's orbits. There's a whole orbit panel where we describe this, but I'll do it for you because I'm here in person. All right? He suggested, suppose you had a hill and you sort of fire a cannonball. Not very fast. It would just sort of kind of fall, right? Fire it a little faster. it goes farther before it hits the ground, doesn't it? Even faster, it'll go even farther. Now, wait a minute, Earth is curved. So if you keep this up, this thing is coming around the backside of the Earth. So he asked himself, there must be a speed sufficiently high so that that cannonball comes right back to the cannon. And all you have to do at that point is duck. And the cannonball ought to just slide on by and stay in orbit. The fact is the cannonball is falling every moment it's there. The difference is it's going sideways so fast that the amount that it has fallen is the same amount that the Earth's surface has curved away from it. That is the speed that gets you orbit. He figures this out. And that's why the moon is behaving the same way the apple is. The apple just doesn't happen to have sideways motion to bring it someplace other than right below. And when you are in free fall, you are weightless. That's the coolest thing to be. We have in our midst an astronaut. We have Tom Hendrick. Hendrick, where are you? Raise your hand. Please stand up. An official astronaut, okay? On several shuttle missions. So you got to admit, being weightless was cool. It's cool. Well, you got to put that on microphone.
It's cool, Neil.
There we go. And so he's in free fall around the Earth. Not only is the shuttle orbiter in free fall, everything in the orbiter is in free fall. So therefore, everything is weightless. Now, if you're in an elevator and you cut the elevator cable, up until the point you hit the bottom, you are weightless. You're in free fall. Here's an experiment you do. It's a very cool, cheap experiment. Take a tall glass of water in a paper cup. Make sure it's tall. One of those that Starbucks it'll cost you $8 to get it, but you'll get a tall cup. Fill it with water. Punch holes in the side. Obviously, the water's going to leak out. The water at the bottom hole will spew out farther than the water in holes higher, because the water weighs more above it. There's more pressure at the bottom to spray the water out. So the bottom one is far, and the higher ones are a little less. It's all because of water pressure, the weight of the water. Take that cup of water while it's spilling, drop it into a sink. It doesn't matter what you drop it into, but this is to minimize mess. Drop it. The instant it leaves your hand, it is weightless because it's in free fall. The cup is weightless, the water is weightless. And if the water has no weight, then the water does not know to exit the hole in the side of the cup that you punctured. So the instant you drop that cup, the water cuts off. It just stops. And the cup falls, hits the bottom, and spills in your sink. But while it fell, it is evidence that the water became weightless. The apple is weightless, the moon is weightless. That was Isaac Newton. On top of that, he discovers the laws of motion. Famous equation, F equals ma. You may remember that from high school physics or not. It's an important equation. You combine F equals ma and the laws of gravity, it gets us to the moon. It allows us to aim projectiles and land where we want on Mars. He also discovered the then known laws of optics. Put light through a prism, showed that white light is composed of colors. He named the colors of the rainbow. Roy G. Biv. Roy, you know Roy G. Biv? Roy G. Biv. Red, orange, yellow. Keep going.
Green. Blue.
Yeah.
Purple.
Was there a P in Roy G. Biv's name? Actually, it's purple to some people, but to Isaac Newton, it was
Violet.
You left out the I.
Indigo.
Indigo. So he threw in, Isaac Newton had a mystical fascination with the number 7, and so there really, to most people, only 6 colors there. He threw in indigo. So, plus it spells Roy G. Biv. You can't give that up. So he puts these through, and here colors coming out of white light. This freaked out the artists, right? Because that's not how colors work in art. And then he took the colors, put them back together, got white light again. So he understood the behavior of light, of these different bands. And so came up with the laws of optics, laws of gravity, laws of motion, and on a dare, practically on a dare. He invented integral and differential calculus on a dare. Somebody said, Ike, why do the planets orbit in this shape we call ellipses? An ellipse, a flattened circle. Why that shape? He said, I don't know. It comes out of my equations, but I don't know why it's that shape and not some other. I'll get back to you. So he goes home for a couple of months, comes back, here's why it's that shape. Well, it's actually a cut from a cone. Take a cone and make cuts in it. You get an ellipse, a circle, a parabola, hyperbola. It's math people know this. This guy would know that who got the arithmetic good earlier, okay? So then the friend said, well, that's cool. How did you figure that out? Well, I invented calculus to find the answer. Most people are struggling with it just to learn it in school. He invents it for no other reason but a friend of him posed a challenging question. Isaac Newton, after all of this, then turned 26. I'm just saying. You read in the back of one of his books called Optics, where he discovers all his laws of optics. In the back, he has queries. These are like stuff he hadn't had the time to figure out yet. Maybe some others will find out. He says, I wonder if the stars in the night sky are just like the sun, except much, much farther away. It's like, yeah, it's like, okay. I mean, he's wondering stuff that became entire branches of study. The crumbs off his plate, all right, are the entire careers of other people. He then, later on, would die a virgin, okay? So just these are factors you might want to consider.